June 2015, Common Core Regents exam for Geometry, Part 3. Answer all 3 questions in this part. Each correct answer will receive 4 credits. Clearly indicate the necessary steps, including appropriate formulas, substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. All answers should be written in pen except for graphs and drawings, which should be done in pencil. So number 32 says, in the diagram below, EF intersects A, B, and CD at G and H respectively, and GI is drawn such that GH is congruent to IH. Okay, looks like we have an isosceles triangle, and as a result, the angles opposite the congruent sides designate congruent angles. If the measure of angle EGB is 50 degrees, and the measure of angle DIG is 115 degrees, explain why AB is parallel to CD. So we want to tell why AB is parallel to CB. So since I need to prove that 2 lines are parallel, I either need to show alternate interior angles are congruent or corresponding angles congruent. The first and foremost is to show alternate interior angles, and if you can't prove that, then you go for the corresponding angles. The first thing I'm going to start with is this angle right here, which is 115 degrees, and it lies next to this angle right here. So since you have adjacent angles lying next to each other on a line, their sum is equal to 180 degrees. So if you subtract 115 from 180, you get a difference of 65 degrees. So both of these angle measures for the isosceles triangle is 65 degrees. And then the sum of 3 angles of a triangle is equal to 180. So that means the measure of this angle is equal to 50 degrees. And as you can see, we have alternate interior angles that are congruent. So the reason as to why AB is parallel to CD is because angle EGB is congruent to angle GHD. Therefore, these are congruent alternate interior angles. Number 33. Given quadrilateral ABCD is a parallelogram with diagonals AC and BD intersecting at E, prove that triangle AED is congruent to triangle CEB. So we want to prove that AED is congruent to CEB. Okay, well, the first thing that I see is that we have vertical angles that are congruent, and there's many different ways in writing a proof. You can explain it all out, write it all out. You can do a T-chart. That's entirely up to you. I'm going to go with the chart with statements and reasons because I'm just used to doing that. And the given information is that we have quadrilateral ABCD is a parallelogram. So you have to think of all the things that you know about a parallelogram. So some of the things are that diagonals bisect each other, opposite sides are congruent, opposite angles are congruent, consecutive angles sum to 180 degrees, opposite sides are parallel, just to name a few. Okay, so the next thing that I see that you don't have to be given any information to denote it is that vertical angles are congruent. So angle AED is congruent to angle CEB. You have to use corresponding angles. We can also state that AE is congruent to CE. And we could also say that DE is congruent to BE. And the reason as to why is that diagonals of a parallelogram bisect each other. Okay, then we have step 4, which is that the triangles are congruent by side angle side. So triangle AED and ultimately is the proof. Triangle CEB, and the reason as to why is side angle side. So describe a single rigid motion that maps triangle AED onto triangle CEB. That would be a rotation. And the reason as to why is because corresponding sides, AE and CE, have to line up. And if you did a reflection, it would line up with BE, and they're not corresponding sides. So that's why it's a rotation. And that would be a rotation of 180 degrees about point E. Do keep in mind this is just one proof that's adequate. There are a couple different proofs that would prove these two triangles congruent, and they may be correct. So if you have developed one where you showed that you have parallel lines, for instance AD and BC, then you can conclude that alternate interior angles are congruent and go in that direction and end up proving the triangle is congruent by angle side. So like I said, you really should get your proof checked by me to make sure that what you did develop was appropriate and adequate and yielding a complete proof. Number 34, in the diagram below, the line of sight from the park ranger station P to the lifeguard chair L on the beach of a lake is perpendicular to the path joining the campground C and the first aid station F. The campground is 1/4 of a mile from the lifeguard chair. The straight paths from both the campground and first aid station to the park ranger station are perpendicular. If the path from park ranger station to the campground is 0.55 miles, determine and state to the nearest hundredth of a mile the distance between the park ranger station and the lifeguard chair. So I'm solving for this distance here, and I have a right triangle. I have the lengths of two sides, so all I need to do is plug it into Pythagorean's theorem. So leg square plus leg square is equal to the hypotenuse square. X is equal to the square root of 0.55 square minus 0.25 square. When it says to the nearest hundredths of a mile, that's 2 decimal places to the right. So that's approximately equal to 0.49. Gerald believes the distance from the first aid station to the campground is at least 1.5 miles. Is Gerald correct? And justify your answer. Well, since I found out x to be 0.49 and I have an altitude drawn in a right triangle, I can use proportions in order to find the length of FL. So I'm going to assign that to be y, and then add the two values that I end up with for y and for LC and evaluate the distance. So y over 0.49 is equal to 0.49 over 0.25, cross multiply, and we get y is equal to approximately 0.9604. And we're going to add that value to 0.25 to get a total sum for FC equal to 1.2104, which is less than 1.5 miles. So Gerald is not correct. .2 is less than 1.5 miles.